All right, on example 2, it says solve the system. Well, we can't use substitution on this one. We can't solve for just x or just y without involving a square root and a fraction, right? And we don't want that. So the other way that we talked about solving systems was the addition or the elimination method. So let's use that, which means I just need to pick one variable that I want to eliminate. Do I want to get rid of the x squared or the y squared? It doesn't matter, it's your choice. X squared. All right, so I'm just recopying down what we had up there. And you said you wanted to get rid of x squared, right? So remember, not always the smallest of numbers, but always works. Take the coefficient in front of the first x squared then and multiply the second equation by it. Take the coefficient in front of the second x squared there and multiply the first equation by it. But check, is one of them already positive and one negative? No, so that means you're going to have to make one of them negative. Do you want to make the top or the bottom one? The top. All right, so we're going to make that a -4. All right, so let's distribute the -4 into the top equation. That -140? Yeah. And distribute the 3 into the second equation. All right, so now let's combine the two equations. What's -12x squared plus 12x squared? Cancels. That's what you said you wanted to happen. What's -8y squared plus 9y squared? 1y squared equals what's -140 plus 144? And how do we solve for y? Yeah, take the square root. And so we get y equals, what's the square root of 4? And? Good. Don't forget when you take square root, do plus or minus 2, okay? So, again, like the previous one, except for now we're dealing with y's, then we had solved for x. We have 2 of them. So we're going to take both of them and plug them back into one of the equations to solve for its x value that goes with it. Doesn't matter which equation we use, so what do you want, the first or the second one?
Wait, we have to put -2 and +2 in both of them?
Yes, we're going to put +2 and -2 into both equations. Or no, just into one equation. I'm sorry. We're going to plug in both +2 and -2, but we only have to use one equation. Okay? Ma'am? Yes, you can go into a different box if you want to on your notes. All right. So let's go to the next slide. I'm going to stay on this one just because my equations are written up there, but go on to your next slide. Which equation do you want to use, the top or the bottom one? All right, the bottom one you said? So we have 4x squared plus 3y squared equals 48. And so we're going to plug in, what do you want to use first, positive or -2? Okay, so let's plug in y equals 2. So we got 4x squared plus 3, we're going to plug in our y squared equals 48. And you said we're going to plug in 2. Remember, you got to remember your PEMDAS, so we're going to do exponents first. So I can't do anything with x squared, so 4x squared plus 3 times, what's 2 squared? 4 equals 48. And then we multiply. So 4x squared plus, what's 3 times 4? 12, good, equals 48. And then let's just solve for x. What do we do now? All right, good. So we're going to subtract the 12. So 4x squared equals 36. And divide by the 4. So x squared equals 9. And then what? Yeah, take the square root, and we find that x is positive and negative 3. Which what that means tells me that when x is negative 3, we said y was 2, because that's what we plugged in. And when x is positive 3, y is also 2. So we got two solutions just from y equals 2.
Wait, when it's a positive, there shouldn't be a negative.
No, both of these, good question. Both of these x's came from only when y was positive 2. So that's why we got y is positive 2 in both of them. Okay? Here we got the x was a negative 3 and the x was a positive 3. But they both came from when y was 2. Which means we still haven't done when y is negative 2 yet, have we? So we've got to do that. So I'm going to have to do it over here because I just don't have any other room. Alright, so then we got to check when y equals negative 2. I'm going to use the same equation. It doesn't matter, you don't have to, but I like to because that means my steps are exactly the same. I just got to work through it again. So 4x squared plus 3 times, what's negative 2 squared? 4. Multiply. Anybody notice anything? Yeah. If you will show me that, okay, I know that this is the same as this, then you can say, okay, then we know x is going to equal what? Plus or minus 3, which means I'm going to get the solution when x is negative 3. What was my y value? Negative 2. And we also got when x is positive 3, what was the y value? Negative 2 as well. So we ended up with 4 solutions total. And they're 4 different solutions. Even though some of their pieces are the same, none of them are exactly the same.